our next speaker. This is representative. Well, yeah, she's our former colleague, by the way, but still, she is representative of Testcontainers at Docker, Anna Chernysheva. Anna, welcome to Javon.
Hello.
Hello,
Hello.
nice to.
Hope you can hear me and see me.
Yeah, I can hear and see you. And by the way, I just
Beautiful.
have the same AirPods here.
Oh,
The same
amazing.
color.
I can recommend. I love them. I love them. It was very good purchase.
Yeah, I just love them. I just decided for the conference to switch to AirPods, like my hair. So like this. Okay, so can you give us a quick hint what your talk would be about?
Yeah, so my talk will be about test containers best practices. I think that a lot of people here already know about test containers, open source. We have a very big community, but I want to highlight some best practices of how you can use this library in Java, what guidance to follow, and share some useful links for the folks who want to leverage their integration testing.
Sounds really great. So I would ask you to start sharing your screen. And meanwhile, I would remind everyone that you can leave questions for our speakers in the chat where you're basically watching us. Could be YouTube chat, could be chat on VR community platform. I will collect all your questions. I said answers, right? I will collect all your questions and ask them in the end of the talk. So, guys, don't miss this opportunity to ask anything you want about test containers because I'm pretty sure most of you are using them. So, Anna, stage is yours. Good luck.
Thank you. All right, so let's start. Brief overview of the talk. I want to first cover what is test containers for those people who don't know about it, how test containers impact developer productivity and speed, and then we will cover 8 best practices that is a good way to follow when you implement test containers for your integration testing. So first of all, quick introduction. I'm Anna. I work at Docker. I'm solution engineer right now, and I joined Docker through the acquisition of Atomic Jar. That is the startup behind Test Containers and Test Containers Cloud. And before that, yeah, as Roma said, I worked for EPAM for a long period of my career. So probably we'll see some familiar faces in the chat when you ask questions. Okay, so about developer productivity and how test containers stands here. I want you to think about what drives your productivity. You can also put this answer somewhere in the chat if we have it. When you reflect on this topic, usually answers that we get during these conversations about developer productivity can be aggregated in 3 main headlines. Is first, cognitive load impacts your productivity, feedback loops impacts your productivity, and in general flow state as a combination of these first 2 impacts your productivity. Cognitive load means that when you use Slack or when you use Teams, emails, whatever, you may be distracted from your workflow by colleagues who ask some questions. You want to answer them right now, so you switch the context. Or you open a new project, you see that it requires refactoring like immediately. It was like not good, and you again switch the context from the top priority tasks. Another bullet is feedback loops. So you want to iterate fast, and you want to get the joy from the development because it's cool, it's funny, it's really great to be a developer. But when you want to get the feedback on your code, on the feature that you implement, you want to get it fast. And if you need to wait for it, like for example, push it to another pipeline stage, wait for a couple of hours, or even less than an hour, but still you have to wait, you will switch to another task. Then you get the feedback about your initial task validation. And if there are some issues, you need to switch and fix them. So you are always in this context switch, which means that being productive is hard in nowadays. I put here link to article, like I liked it some time ago. It describes in more detailed way the productivity issues, and that when you have this constant context switches, you change from your attention from one task to another, from writing the code to fixing the flaky tests. You get this context switches and you can't get into the flow state. Also, based on this article, author says that after approximately 15 to 30 minutes, you get into the flow states, and this is the state where you really enjoy what you are doing, where you can feel your productivity, you are focused, nothing distracts your attention, you can accomplish the tasks, and after the day of this productive work, you can say that, okay, I'm happy with what I'm doing, I was very productive, I implemented great features, everything is fine. So the faster you get the feedback, the more productive and more happy you may feel. So the feedback loop often struggles with the stage when it comes to the integration testing. There are different approaches how you can do it. For example, you want to test your application against the database, you want to test it locally, and you can install the database. You can have H2 configured with your project, or like you can use some mocks to imitate another service in addition to the database. But still, it will be kind of fake. And when you push your code further in the CI pipeline, your test may fail because it works with H2, but it doesn't work with real Postgre. Or the worst case scenario, there will be some critical defects in the production. Another pretty popular way of doing integration testing and trying to speed up things is having shared instances on the staging or QA environment. So, for example, you have the same Postgre on your staging, you run your tests, but let's say another team is running tests at the same time, and you end up with flaky tests because another test rewrite the test data in your Postgre, and there were no data that you expected to be during your test scenarios, and you need to go and spend some time, understand why tests are failed. Either it's because of some bugs, or is it because of just the flakiness and issues with the test data. And this approach, it again slows down the feedback loop. Or like another case is test in production, but we will not focus on it. It's pretty rare, but still used in some organizations. So how test containers and in general integration testing was transformed with this approach of running tests locally or on staging, like how we can do this. So first, when Docker came into place, we were very happy because we can run things in containers. So we can run Postgre in container, and we can run it locally without downloading the real instance on the machine. And we can test things with different versions of Postgre, for example. Next thing, if you want to run more complex application with not only Postgre, but start our application with Kafka and another dependencies, we can go with Docker Compose and define what services we want to start with our application. Again, run it locally, test things. But the next approach, which is Testcontainers uses as a baseline, is Docker API that helps you to make your tests more developer-oriented and more flexible. So here we come to stage of introducing test containers. You can think, so this is the open source library, and it provides you with real instances, like with lightweight instances of real services, like real databases, real message brokers, put it into Docker containers. And you can access these services through the programmatic API. So you can think about it as programmatic compose. You just define what you want to start, like in this case, I have Redis example, and you have your Redis up and running. This is pretty convenient, like we have a big community, more than 30 million pool per month from the Docker Hub, and we have a lot of public cases from Spotify, Netflix, Uber, etc., talking about how they introduce test containers to their integration testing. So how it works? You can think about it as a high-level Docker DSL because it is based on the Docker API. The one requirement that you need to fulfill when you run test containers test is to have Docker available, like the Docker context, so your tests can start the containers. In your IDE, you define what you want to start, and when command start is executed, it will be interpreted into the Docker command that will interact with the Docker host, with the Docker daemon that's running on the Docker host, that will pull the image, start the container, and gives to your code information about this container, the port, the host, environment variables, etc., like everything that you can get from the Docker container. In this way, you can make your test self-contained. So you can still be in the inner loop. You can get the feedback real fast. And you can, by spinning up real services, like real environment that you need for testing on your local machine, this environment will be the same as you use in production. It will be on demand, so test containers by default looks up after your containers. When you start test, containers will be started. When tests are complete, containers will be automatically destroyed. So you don't need to worry about resources. It also starts container on the random port, so you don't need to worry about what ports are available on your machine. You can just leverage your environment setup for testing to test containers, and it will manage all the things for you. So the best practices. Let's start with the first. Actually, two. They go very close together. Maybe a bit obvious, but let's go with examples. So first of all, we recommend not relying on the static host and port. So do not hardcode these things. And let's look why. Let's switch to the IDE. So here I have an example of Redis. This is how you can set up Redis with generic container. It exposes the port, and let's say I just introduced that container to my test stack. And I had this connection to Redis pool. So in my test, I want to connect to Redis. I want to put some values, and I want to get these values to understand that connection works properly. Like very, very simple thing. How do you think would this test run or not? Let's run it. All right, it's failed. Let's take a look why. Connection refused. Yes, we can't connect because of the hard-coded port. When you use test containers, the beauty of this technology is that you get information about container in your code, and you get it on demand, like live. So you can say here, Redis, get mapped port, and provide here the port that you want to get for what's wrong here? No, something is with my IDE. Oh, I used get first map pop. Just get map port. Yeah. You can actually go with first map port here as well, because this is only one port here. If we run this test, again, you will see that it is green. Yes, now we can connect to Redis and verify things here. So you may ask why we shouldn't leave the local host here. We can. Test will pass locally, but if you run your tests in CI with the connection to remote Docker host, they will fail because there will be no application available, like no Redis available on the local host. So the same thing here. We can do Redis get host, and in this example, it will get the real host where Redis is running, and you will be sure that your connection is stable. So coming back here, don't be default with it works on my machine. It should work everywhere, and just utilize Testcontainers API to get the information about the containers. And again, if there is only one port that you expose, you can get the first map port. It will also work to get the port of the Testcontainers based container. Let's go to the next one. Again, pretty obvious, don't hardcode container name. Let's take a look what will happen if we do this. For example, the same Redis, you want to run the container, but you want to be sure that this is Redis. So you want to say, this is my Redis container. You can do it like this with Testcontainers implementation. So just execute the command inside when you start the container. So here I have two tests. They just put the value into Redis and get the value, and I start container before each test. Like, let's say this is my use case. I want to do this. Let's take a look what will happen. I think you already guessed that one test will fail. Yes, and it fails because the image conflict. So you can't start two containers with the same name. So if you just remove it, you will see that tests are green, and each of my tests, it logs the container name. So here you will see that there were two different container names used, and like this is fine because we can get the container name using Testcontainers API. So if you want to know the name of your container, you don't need to hard code it. You just need to ask Testcontainers to give it to you. So here, if you want to run your containers with the same name, here's how it may look like. You don't know if there is a GDI or if it's an evil in this like covering under this same name. So don't hard code. And again, as like the general rule of thumb, if there is no Testcontainers API available for some type of Docker feature, then it is intentional move. So Testcontainers provides the API that follows the best practices for testing, for integration testing. There are some cases probably where you want to use some Docker features that are not available in Testcontainers API, but this is usually the rare cases. And we suggest following the API that is available, meaning that you will follow the best practices by default. Okay, the next one, again, pretty obvious, but we still are seeing this implementation in some test cases because it's like the easy way. You can use sleep to wait for container and then move forward. It's like just one line. But let's take a look how it may look differently. So here I have example, the same Redis and another Nginx. Let's say I want to test something with reverse proxy, and I want to start my Nginx after the Redis is starting. I can use thread sleep. It's pretty easy. 2 lines of code. I start Redis, then sleep, start Nginx, then sleep, and yeah, this should work. And actually, if I run this test, you will see that they work. Containers are started. Yeah, it's like 7 seconds, close to 8 seconds. Not that big difference. But let's take a look how we can do it differently. So there is waiting for method like API, programmatic API that is available in Testcontainers that gives you a wait strategy that you can utilize to wait for container. So here in this example, let's wait for the log message. I have it here. We know that when we start Redis, it should give the log message that it's ready to accept connections. And the same for the Nginx, we can actually put the rule annotation here and say that it depends on Redis. It means that Redis, when you start Redis container, Testcontainers will wait for this log message available, and when Nginx container will be started, it will start with the rule that it depends on Redis. When Redis is available, then Nginx will start. So we can delete these 2 thread sleeps and run tests again. And it was like 2 seconds. So this is just for one test. 8 seconds with thread sleep and 2 seconds, like let's say close to 3 seconds without, just with the wait strategies. But if you have not 1 test, not 10 tests, even like not 100 tests, but like more than 100 tests, like the big test suite, and in every class you want to wait for containers to be started, the wait strategy will help you to speed up your testing. So if you're using thread sleeps in some places, take a look at the wait strategies that are available in Testcontainers. There are plenty of them, and they may help you with reducing the time of your tests. So yeah, don't wait for tests, just use wait strategies. I provided here the link. I think it will be shared after. I can share it after in the chat as well, with detailed list of the wait strategies that are available in Java Testcontainers implementation. So here I use just this simple one about the logs, but you can combine them. So for example, if you want to wait for some port being available and for some log message being present in your container, you can aggregate these 2 into combined wait strategies. So your container will be considered as fully started and available for your tests only when these 2 conditions are fulfilled. You can also do more complex health checks, call some APIs, input some command messages, or like execute some commands in the container and wait for response. A lot of things that you can do, just use proper wait strategy. The next thing is related to generic containers and the modules. Let's take a look what I'm talking about. So the basic construct in Testcontainers is generic container. This is the basic class that you can use to start your containers, like any container. Here is an example how you can start Postgre with generic container. You provide your image, then you know that if you want to start Postgre, you need to expose this port. you need to provide environment variables like username, password, database. You can copy files to container with your test data, and you want to wait. Here is another example of how you can wait for container to be ready. So it's log message strategy. You want to wait for this log during like this period of time. Then when container is started, you want to connect to it. So in your connection, you just specify the JDBC URL. You can get it from the aggregation of the container host and container port. And then you provide username and password in order to connect to this Postgre instance. Then you can execute your tests. Here in this example, I just, so I have this init data here. It just creates some to-do list. And I verify that it contains from like proper amount of completed to-dos. Simple thing. I can run it, it will pass, like, all good. But if you want to use Postgre not only in one class, but in multiple classes for different test scenarios, you will need to copy and paste all of this stuff. So Testcontainers has modules, which is the high-level abstraction over different technologies. And we have Postgre module. So you can just start the Postgre container. You say it's new Postgre container. You can put the image name here. You can, again, fulfill it with the test data. And we can, let's actually remove it and name it Postgre. So this is how you can do the same thing with Postgre module. Next, you want to connect to this module, right, to the Postgre. So you don't need to do this complicated things with get host, get port. You can do just Postgre get JDBC URL. You can do Postgre get username, put comma here, and Postgre get password. This is much more easier way. So if we run the tests, you will see that everything should be good. I think I didn't do any typos. Yeah, all good. You have your Postgre instance in like 3 lines with predefined data. And it's very easy to connect to it. You don't need to remember what was your username, what was your password. You just get this information from the container because it is already implemented in this module. So if you go into implementation, you will see that this JDBC data container extends generic container. So it's kind of more high-level abstraction that already stores some information about how you start Postgre. And it relates not only to Postgre, there are a lot of different modules available. So the more bright example is with Kafka. So like if you want to run Kafka in generic container, like you may end up like this, because you need to know information about Zookeeper, you need to know information about hosts, ports, all of these relations. And if you want to migrate Kafka start from one test class to another, it's a nightmare. But you can use modules. So this is just a summary, and here I have a quick screenshot of the modules. You can go to Testcontainers official website and take a look what modules are available there, sort by languages, And we have also official modules program. So, for example, like CockroachDB, Dapper, these modules, they are official, meaning that the companies behind this technology, they are responsible to maintaining the module code in the up-to-date state. So most of the modules in Testcontainers catalog is community maintained, but those who are official modules, they are maintained by the team who developed the specific technology, meaning that if there is something new available, like in Dapper, then the team behind it will make appropriate changes in the module implementation. Let's go to the next one. Also pretty simple one, but again, I saw a couple of times people are using it. So when you run your tests, sometimes you want to run it with the latest. You don't want to scroll what is the latest tag, like what is the exact tag, or you don't know what is the version in your production, or it's in transition state. I don't know, you don't get this information. You want to run with latest. But this is not that good approach. So why not? Let's take a look at some example. Let's say you are using Mongo in production and you use old version like 3.6, and you are in the process of migrating to the new one like 4, more than 4. So in the recent versions of Mongo, you can use transactions, and you can use it like to communicate with the database. Old version of Mongo doesn't support it. There can be like some confusions when you write codes and when you run some tests, and if you always tend to use the latest version, it may appear that you run tests with the latest that should not pass because your production version is still old. So if you run these tests with the latest version, you will see everything works good. Like you can insert with transaction into the table, all good. But if you change the Mongo version to specific one, 3.6, you will see that these tests will fail because Mongo 3.6 doesn't support transactions. And when you try to start the transaction, it will fail. So yeah, test failed. But if you use this code not in the test, but in the real application, there can be issues that discovered further in the pipeline or in production. This is just a very probably obvious use case, but there can be other use cases with databases where some types of operations are not supported in the older version comparing to the latest versions. And if you use latest for your testing, everything might be good, but in production, some things may fail because of incompatibility of the operations. And yeah, let's not be folks with everything like it works on my machine. Let's think about the wider picture. Again, in general for testing, being specific is very important because you need to know exactly what you are testing, with what environment, with what versions, to be sure that everything works as expected with the proper versions that you use in your production code. All right, let's move to before each. In some of the previous examples with container name, I showed that I run my container in the before each annotation, which is not the best practice. It can be done for some use cases. So in this case, I used it just for demo purposes. Sometimes you may need to run it to Again, test some negative scenarios. Maybe some test case will fail your database, and you want to be sure that another test cases will not be affected by it. But let's move to the lifecycle strategies. So I hear usually this question a lot about the proper lifecycle, how to optimize test containers usage, how to start containers in a more efficient way. So here I want to show a couple of examples. So again, before each, not a good practice. Let's start container before the class. How you can do this? The same like Postgre example, but here I have like very tiny implementation of my customer service. So I have a customer with ID and name. I have customer service that can create customer, get customer from database, get all customers, like all of this stuff, and my database connection. Very, very simple, not Spring Boot oriented, but to make the demo clearer. So you start your Postgre as a static, which means there will be only one instance of Postgre available for this class. Then in before all, you just say start, you can have your connection, and after all, you can stop it. This is very manual usage of the test containers lifecycle. So here you see the tests are passed, like all good. But no before each. More interesting things are here. So in the JUnit 5, you can use test containers annotation with the container annotation. So here I put it test containers annotation above the class. It means that it will look for container annotations inside of the implementation and will start test containers that are marked with container annotation. So here I defined it once, and before tests, I just create the connection, delete all the data to have the state clear for each test. And here I print the container name in my two tests. Let's run them. Okay, tests are done, but you see that container names are different, meaning that with this approach, for each test was created its own container, which is not good, the same as before each. But if you do static, then only one container will be created for the class. It is pretty often mistake when folks are using test containers and container annotation. So it's important to remember then test containers look for container annotation. If the container is a static field, then it will be started once. If it's an instance field, then it will be started before each test. So here you can see container name is the same. So we started one container before whole test suite in this class. And another example, singleton approach. So here you define the abstract class with test containers that you want to start. Again, I have a Postgre example. If you have more containers, you can run more. Important thing here is to put them into the static block and start them in the static block. In this case, you will have one container for not class, but your whole test suite. that extends this abstract class. So you start your Postgre, you can define your connection once, and here and before each, I just log the container name. I have two classes, like first one that extends abstract integration test, two tests that just create customer and get one customer, get all customers, and the same set of tests, like very similar, but with another test data for the second class. So let's run them. All right, tests are done, and you see that for my tests from two test classes, they used the same Postgre container. This way may optimize your test speed like dramatically. If there are test cases that verifies the positive flow, it is totally acceptable to have one instance of Postgre. You know, the test will not break it. They verify like some general flows, and you can have only one instance for the whole test suite. It will start once, and it will be destroyed after the whole test suite is complete. There is one common misconfiguration that we see when people use singleton. You can think of using test containers and container annotation for your container and do not use static. So you define it once, then you extend in your test class implementation abstract class with defined containers. Let's run them and see how containers will behave. Okay, tests are done, but you see here and here for each test class was used each own instance of Postgre. So in this implementation, test containers annotation rules the container, and even though containers defined as static, it will be applied for each class. So be careful with this when you implement the singleton. This is, again, we see that test containers and container annotation often raises some confusion of how it should be used. All right, let me delete it. Good. So no before each. When you use before each, your resources and test execution time just burns. You may end up with very long test cycles and then complain that test containers are not the proper tool because it works so long. Using the proper container lifecycle may help you with optimizing the test speed and like using the technology in the way it was designed to be used. Again, quick summary about before all and test containers plus container notation. Singleton, there is a guide on our page. I will show the detailed list of links at the end of the session. So there is a big blog post that explains one more time the best ways of using container lifecycle and what are the common misconfigurations are, so you can avoid them. And the last but not least, you can utilize the integrations from your framework that are available for test containers. For example, if you use test containers with Spring Boot or with Quarkus, Micronaut, all of these frameworks, they provide their own vision of how you can use test containers within their framework. Let's take a look at the Spring example here. So the test I showed before, they were a bit separated from the application lifecycle. It was just examples, how you can start containers, how use them, wait strategies, lifecycle, and so on. But the real example, if you want to run containers with your application, you want to tell your application to connect to exactly this instance of Postgre, not another, like not that one that is on your staging environment, but this one that is running with test containers. How you can do that? I have here pretty simple to-do app. It has to-do repository that can get pending to-dos. I have here to-do controller that can get to-do by ID, can save, can update, delete, and so on. Very, like, just the base simple implementation. Let's say I want to test this application. First of all, I can start with the repository testing, meaning that test how my implementation works well with real database. If my repository really can put data in the database, get them properly, maybe modify. So here I can leverage test containers for the repository testing by using test property source provided by Spring. And in the data source URL, you just provide the connection. So here, important thing that you put the test containers in the line, and then you define what version of database or like what other technology you want to start. So here I have a couple of tests that will just save to-dos and verify that they are saved correctly. Should delete the to-do, I save them, then delete all, and expect that everything will be deleted from my database. So if I run this test, they should be good to go. All right, yeah. So here I used test containers Postgre database, and afterward my implementation of to-do repository to test how it works. But if I want to test the APIs, there are two ways of how you can do this with Spring. If you are using Spring, like old version of Spring, less than 3, then you can go with dynamic property source. So what's important here? Again, I utilize test containers annotation. It will start one container. I inject test data again through the Spring Boot SQL annotation. I have it here in resources. This is a bit of test data that I use for my test scenarios. And here in dynamic property source, I rewrite the Spring Boot application properties with the data from my test containers container. So I say that data source URL should be JDBC URL from test containers, that the username should be username from my Postgre container, the same for password. If you need to provide more information about how you want to start the Postgre, again, you can utilize test containers API for that. And then, I just need to define the port, expose it to test containers, and this test will start the application. I can call the endpoints of it and verify that things are working properly. So let's run them. Okay, it's initiated. Good. Test passed. Very good. If you're using Spring Boot 3.1 or newer, then you can use a more advanced approach of how to connect your application to test containers-based containers. Here's the same example, the same set of tests, but they look clearer. I just provide here the test data, and I extend in my test implementation the base integration test class. Let's take a look what it does. Here, the same thing that were in the old implementation. I need to get the port and I need to expose it to the test containers. The important thing here that I can import container config class where I can define my containers. In this container config class, I define Postgre, but I do not put the information about the container into data property source, into the data registry. I just use this service connection annotation. So the service connection is available in the Spring Boot greater from the Spring Boot version greater than 3.1, and under the hood, it just implements how your application should talk to this test containers implementation. So test containers team work very closely with the Spring team, and you can check that there are always some new things coming up with Spring because they recommend using test containers as a tool for integration testing. If you even go to the Spring websites and generate the new project there and select that you want to use some test frameworks there, the project will be generated with everything needed for test containers test to work. So coming back here to the implementation, once again, I have container config with service connection annotation that I can put under on my container. Then I just use it for the base integration test, and I extend my test class from this base integration test. In this approach as well, my Postgre will start only once for the whole test suite that extends base integration test. So let's run these tests and make sure that everything is working properly. Okay. Good. Test passed. Another advantage of this type of implementation with container config and like the service connections is that you can start your actual application locally reusing the same configuration and the same set of containers. So here I have an example of my test application, how I can start it. So I say that I start my application from the main with container config class, meaning with Postgre that I defined there, and like I just run it. Let's run it. So you see in this example, application started initialization. Okay, it is started, and I can go to like, the entry point. This is my application. If I go to Docker Desktop, you will see here that Postgre is running, and I can test things like in my test data, I have a to-dos table, and I have some test lines about my to-do list. I can mark them done or not done, verify the things in database further if I need to do so. So This approach with container config and service connection notation allows you to define test containers environment once and then reuse it for either local development use case or for your integration testing use case as well. Let's stop the application and come back here. So yeah, we have 4 minutes left. Let's wrap it up. Quick summary of what we discussed today. First, as a best practice, use available test containers API to start the containers, to get the information about the containers. If API is available, it means that it is the recommended way, it is the best practice of how containers should be started and what information you can get from it. There is also a link about how you can create containers, like the best practices of it. Wait strategies, this is important to utilize them in order to, again, speed up your test cycle, not to waste some time on just some waiting, but you can utilize native things from test containers to wait for your containers. Modules, again, if there is some module available, it's better to use it because either community or official maintainers contributed to the detailed implementation of how you can start your container. It will just save time when you reuse the specific technology. Latest, don't use latest. This is general rule for testing. Proper container lifecycle. A lot of strategies are defined in our blog posts, but again, don't start containers in before each. It's better to use one container for the test class or one container for the whole test suite. And yeah, leverage your framework's integration to utilize test containers. It just helps you to follow the best practices way of either your framework or test containers. All right, this is it. If you have questions, I think we will ask them after this session. There are some useful links that you can use. Test containers website guides that contains a lot of information that we covered today about the best practices and how to get started or leverage test containers with your framework. If you want to check another container runtimes, we have Testcontainers Cloud for that. And on the GitHub, awesome test containers, you can find examples of how you can use it with different languages, with different CI/CD pipelines, how to run tests, and so on. And yeah, join our Slack if you have questions. The whole team is there. They will be happy to help you with questions, with answers. Yeah, so thank you. And we are always open to questions and happy to help. So please follow the links, join Slack. Hope to see you there.
Thank you. Thank you very much for a great talk. A lot of insightful information with details, examples. That's really great. And I always love such talks because they always can be revisited, right? Just to check, okay, how to do this stuff, how to check that. So thank you very much, Anna, for being part of Java One and for your talk. So we do have a couple of questions. You touched them partially in your talk and in the last section, but still, let's try to address them. So first one is pretty technical one, and the question is: would Java unit test with test containers work properly within GitHub Actions on macOS IRM 64 environment?
Okay, I am trying to connect GitHub Actions to macOS.
I think when you use GitHub Actions, you select the base image where you will run it, and there is one of the base images is basically macOS image, because if you run GitHub Actions for Objective C or Swift, you need macOS basically to build it. So I think this is the base of this question.
That's interesting. Like usually for GitHub Actions, use cases that we see the most, they are actually like Unix based or self-hosted runners based. So if image is the main question is the image. Testcontainers is just a way how you start these images. If image is compatible with operation system, you will be able to start this container. If it is not compatible, we have Testcontainers Cloud, which is alternative runtime, Unix based. Every container will be able to start there. For the GitHub Actions, if you go with standard way of how you run it, you don't use the self-hosted runners, then it usually works fine. If you use self-hosted runners with different OS or like different types of machines, there can be issues, or you need to go with Docker and Docker. Again, we have Testcontainers Cloud for that. So if images are not compatible, test will be not able to run. If they are compatible, they will run properly.
Okay, thank you for the answer. Next question is a bit tricky, and you touched that in the last part when you said that test containers could be created by community. So the question is the following: let's say our colleagues and one of our speakers basically they spoke about the experience of creating some cloud service, some messaging system, some database custom. So what would be the steps to create test container for this custom system and to provide it for the community?
Okay, let me go here. If you go to the GitHub page, we have here modules. There should be modules somewhere. Community module registry. This is the way how you can contribute your module to the community. Detailed instruction, how to do it, how to do the pull request. If you want to use your in-house technology for like your testing, and you want to share it with other developers, but only within your organization, you can again build the module around this technology and just post it into your Artifactory or whatever you are using. It will be just a jar file that can be included into your Java project. So this is the instruction for community maintained modules.
Great. And I think I mentioned it yesterday when we spoke about Spring and open source projects. So Test Containers is open source project. So guys, if you see something which you can contribute, I highly encourage all of you not to be shy, not to just say, it's not working. It's working. And you can be part of that. You can just go create your merge requests. Yeah, I do encourage all of you not to be just users, but you can be part of any open source technology. So yeah, please be the part. Okay, I think last question we can cover today because of time. Maybe you can give us some good practices, some advice on how to ensure that your containers have enough resources like CPU and memory to for tests to be executed fast.
It would depend on your either local Docker settings, I think, or on your remote Docker host settings. We have detailed documentation around this. I believe I need to double check. It's not the very often used feature. But yeah, I believe we have an API that will provide you information about how much resources container utilize. But again, if you know that your machine is not powerful enough and you experience issues with just local Docker, most likely it will be the same for test containers-based containers.
Okay. Yep. Thanks a lot. So I think that's it. Thank you very much again for such a great talk. Thanks for being part of Java One, and hope to see you in future conferences. Thank you very much.
Thank you.
See you. Bye bye.
Bye-bye.